This will be a little review of fractions, continuing our work. And again, I think the protocol would be to write the example down and then work it, and then, follow up with what I'm showing you. So as we start this, we're going to take a look at our first example, 5/12, and we want to make it into a fraction, an equivalent fraction, with a denominator of 48. So this would be the protocol to follow. Now, what do we have to multiply 12 by to make it a 48? And if you said 4, but we are allowed to multiply anything by 1 and not change its value. And 1 takes many different forms. For instance, if we said 4/4, that's 1. And if we use this form of the 1, 4/4, when we multiply our denominator, we get 48. When we multiply our numerator, we get 20. So our equivalent fraction with a denominator of 48 of 5/12 is 20/48. Now let's do the same for this. 3/5. We want an equivalent denominator of 60. Now, what do we have to multiply 5 by? And if you're not sure, just divide 5 goes into 60 how many times? 12. So we're going to multiply this 3/5 by 1. And the form of 1 we're going to use is 12/12. This way, when we do that, our denominator, 5 times 12 is 60, and 3 times 12 is 36. Now in these next few, we're going to do sort of the opposite of this. We're going to see if when we tease this apart, are there common factors like 12/12, 4/4, that is a 1, that in a sense we can cancel those out. So again, part of this is a little brainstorming. I know I can take a 3 out of there, 3 times 9. And I can actually do it this way. 3 times 3 times 3 is 27. And 60 is, let's say, 2 times 10 times 3. I get here 2 times 10 is 20 times 3. I could have factored this some more, but there would be no common factors. So the only common factors we see here is one set of 3/3, which is a 1. So then now this becomes 9/20. There are no more common factors of 1 hidden in these equivalent forms here. Now as we look at this, every number is over 1. So to simplify this, this is just going to be 21. Now, for this one, again, the 48 is, we're looking for common factors, 6 times 8, and 6 times 1. 6 times 8 is 48. 6 times 1 is 6. We now have a 1 in the form of 6/6. that we can, in a sense, cancel out as a 1, and our answer here is 8. And you might say, couldn't we just divide 6 into 48 and get 8? Yes, that would have been another way of doing it. Now, as we continue, we want to look for strategies. Here we see 130, 210. I guess this is 13 times 10. And this is 21 times 10. And you can take that 10 out of 10 is a 1. But often when we see something like this that ends with a 0, the shortcut way is just cancel out that 0 in a sense, which is you're dividing out a 10. So then this is left with 13 over 21. 13 is prime, so this cannot be reduced further. And this is a rule we had mentioned earlier, that anytime you have a number divided by 0 other than 0 in the numerator, then this is undefined in our math system. And keep in mind this one, 0 over 11, is 0. 11 times 0 is 0. But when it's divided by 0, watch this, because many students get this confused. It's undefined. Now, in these next few, we're going to multiply, and then later we'll do some division. Now, multiplying, we can think of all of this 2 times 7 over 3 times, now this 4 we can factor into a 8, factor into 2 times 4 here. So you can think of it that way. So we can do what we call some cross-canceling. 2 will go into 2 once. 2 will go into 2 once. So now we're left with just a 7 in the numerator and a 12 in our denominator. And again, you could have done it this way. 1, and taken out a 2 out of the 8 and get a 4. And this gives you 7 twelfths. But in the background, this is what we're doing. Now, I'll write this out here. 4 fifths times, now notice 25 is 5 times 5. 28 is 2 times, or let's say I'm going to take a 4 out of there actually. And you're brainstorming and thinking about these things here. So this would be 4 times 7. I could have done 2 times 2, but leaving it this way is better. So now we have a 4 over 4. So these just cancel out and give you a 1. One of these 5's will cancel out. So your end answer is 5 sevenths. Now you could have done it this way. 5 goes into 5 once, 5 goes into 25 5 times. 4 goes into 4 once, 4 goes into 28 7 times. And now you're just left with 5 sevenths. Now, for something like number 10, and I'll clear this up. Again, pause, write it down, give it a shot yourself. We have to convert this from its mixed number form into its improper fraction form. So we multiply our denominator times the whole number, gives us 8. Add the 1, so that's 9 over 2. This is the improper fraction form of this mixed number. Now this is going to be 5 times 3 is 15. 18, add the 3 to it, over 5. Now can we do any cross-canceling? And the answer is yes. 2 will go into there once. 2 will go into there 9 times. We now get 9 times 9 is 81 over 5. Now this is an improper fraction. How many times will 5 go into that? And I believe it's 16 times, with 1 left over. 5 times 16 is 80, and then 1 more. Now we're going on to division, where we always convert division, which is what we have here, to multiplication. We convert the sign to multiplication, and we take the second item and flip it. That is, take its reciprocal. So the rule is convert division of fractions to multiplication of fractions. You do so by changing the sign from division to multiplication and taking the reciprocal or flip the second term. And again, you can see we can cancel out. 5 will go into there once, 5 will go into there twice, 2 will go into there once, 2 will go into there 3 times, and now you're just left with 2/3. And for number 12, we have 2/5 times the reciprocal of this, 12/10. Now, 2 will go into there once, 2 will go into there 5 times, but there's no other common factors. So we end up with 12/5. And to change this from a improper fraction to a mixed number, 5 goes into 12 twice, and 2 left over that you put like so. Now notice, 5 times 2 is 10 plus 2 is 12, so you can easily go back and forth. But often your math lab will accept improper fractions. Okay, there's a little review for any of you who wanted to do a little bit more work with fractions.